Hello and welcome to the video. In this video we are going to talk through the idea of expanding brackets when dealing with surds. So hopefully we know by now that a surd is an irrational number and we often include it in calculations so we don't lose any accuracy in our calculation. So because of that we need to be able to add, subtract and multiply with surds. So a very common exam question is that you're asked to multiply two surds together in the form of an expanding double brackets question. So it's a very typical exam question to look at multiplying surds, expanding and simplifying. So before we have a go at this question, I just want to recap on expanding double brackets using algebra. So if I was to give you this question and I asked you to expand the double brackets, we'd go ahead and do 4 multiplications. We would do y times y, so we'd multiply the first two terms. That would give us y squared. Then we'd follow the big red arrow. Y times 6 would give me 6y. And then we'd also multiply everything in this bracket by the 3. So 3 times y would be 3y. And finally, the big blue arrow, 3 times 6 would be 18. So what we would find is we're left with 4 terms. Y squared plus 6y plus 3y plus 18. So these were the 4 answers to the 4 multiplications I just did up here, and each arrow shows you one of those 4 multiplications. Once I get to this point, you'll see that I've got a plus 6y, which I can put together with a positive 3y. So I can just simplify my answer very slightly. There's nothing I can do with this y squared, nothing I can do with this 18, but I can add the 6y and the 3y together to give me 9y's. So this would be my expanded and simplified form of this. So this is a double bracket. Once we expand it, we're left with a quadratic expression. This and this, they mean the same thing. So they both mean exactly the same. But the process of getting from here to here helps us to work with surds and to multiply surds. So let's apply that idea to expanding this double bracket, including some surds. So we've got an irrational value of root 5. So that's going to just cause me some little complications as I go through and do my expansion. Okay, this is what I'm aiming for. So let's see how I got there. 3 times 5 gives me 15. Very straightforward. Then I do 3 multiplied by root 5, which gives me 3 root 5. Remember, if this was an x, 3 times x would just be 3x. So we treat it like algebra. Then I'm going to take the root 5, multiply it by 5 to get 5 root 5s. And then finally, root 5 times root 5, which is the same as root 5 squared. So the square root and the squared would cancel out, and I'd just be left with the integer 5. The method I've just talked through, similar to the method on the first slide, you may hear it referred to as FOIL, because we do first, then we do outer, then we do inner, and then we do last. So it's just a way of remembering the 4 multiplications that you're going to go ahead and do. So now I've expanded my bracket, but the question also asks me to simplify. So what I can do here is I can put my normal numbers together. 15 and 5 can go together to give me 20. And I'm also going to put my root 5s together. 3 root 5s add 5 root 5s is 8 root 5s. So my final answer after I've simplified would look like this. I could have wrote it as 8 root 5 plus 20. It would mean exactly the same thing, but I prefer, for a bit of consistency, just to present my answer like this. Okay, let's have a go at another question. So this time I put a negative in one of the brackets just to see how much difference that makes with my question. This is what I'm aiming for. This is my line of method. 2 times 5 gives me 10. 2 times negative root 3 gives me negative 2 root 3. Root 3 times 5 gives me positive 5 root 3. And then finally, root 3 times negative root 3, the root signs would cancel out just to leave me with minus 3. So just make sure you've understood where those negatives are coming into play due to this negative. Now I'm just going to simplify. 10 take away 3, because this is a negative 3, is going to leave me with 7. And then I've got a negative 2 root 3s, and I'm going to add on 5 root 3s, which is going to take me to positive 3 root 3s. So my final answer is going to look like that. The integer 7 and the irrational part of my answer, 3 root 3. Okay, another common exam question is to present the question looking like this. And a lot of students may go ahead and square the 2 to get a 4 and square the root 7 to get 7 as an integer, and then they think that they've answered the question correctly because they've squared both terms. But of course, just like when we're dealing with algebra, if we're asked to square the bracket, we need to multiply the full bracket by the full bracket. So your method this time would look like this. So I wrote the question out again. The complete bracket multiplied by the complete bracket again. 2 times 2 gives me the 4. 2 times negative root 7 is negative 2 root 7s. Negative root 7 times 2 is negative 2 root 7s. Negative root 7 times negative root 7 is positive 7. The square roots cancel out, and the negative signs, 2 negatives making a plus. So then when I come to simplify, I've got 4 add 7 to give me 11 as my whole number, my integer. And I've got minus 2 root 7s. Take away another 2 root 7s is going to take me to minus 4 root 7s for the irrational part of my answer. There is my answer to this expansion after I have simplified my answer. So remember, this looks a bit of an odd answer, but it is correct, because remember, root 7 is a number. It's just the fact that it is an irrational number, so it is a decimal that does not have a recurring pattern and goes on for infinity. So we could change this to a number and round it to 2 decimal places or 3 significant figures. But remember, the main advantage of dealing with surds is that we don't round, so we don't lose any accuracy in our answer. So although this looks quite complicated at first glance, if we were to change it and round it as a decimal, we would lose some accuracy. So this is actually a better mathematical answer. Okay, a couple more examples from me. If you are happy with what you're doing, of course, you can pause the video and go ahead and answer this question yourself. What we're aiming for is this. So the question's presented a little bit differently this time. The surds, the irrational elements, are at the beginning of the brackets. The irrational terms are at the beginning of the brackets. But the method's the same. Root 5 times root 5 is just 5 because the root signs cancel. Root 5 times negative 6 is negative 6 root 5. 3 times root 5 is 3 root 5. And 3 times negative 6 is a negative 18. So then I'm left with 5 minus 18, which is negative 13. and minus 6 root 5, add 3 root 5, which would give me minus 3 root 5. So I could put my answer together to look like that. So again, this is my answer after I've expanded and simplified this set of brackets. Last example from me before I give you some tasks to work through. Okay, so this time we've just made the question a little bit more complex by putting this number 4 in front of the root 2. Let's see what difference that would make to my working out. Okay, 2 multiplied by 5 gives me this 10. 2 multiplied by root 2 gives me this 2 root 2. Then if I go for 4 root 2 times 5, 4 times 5 is 20, so 4 root 2s times 5 is 20 root 2. The final bit is the bit that some students find a little bit tricky, a little bit difficult. 4 root 2, when we multiply it by the root 2, we deal with the root 2's first. So root 2 times root 2 would just be 2, because the square root signs would cancel, and then I use that 2, multiply it by this 4, which was in front of the root 2, which is where this 8 comes from. So just to summarize, 4 root 2 multiplied by root 2, the two root 2's would cancel out the root signs to be left with just the integer 2, which would then get multiplied by the 4, which would then go together to give me this 8. Now I can go ahead and simplify. 10 plus 8 is 18. 2 root 2's plus 20 root 2's is 22 root 2's. Here is my answer. Again, I could put that into a calculator or work it out as a decimal and round my answer to significant figures or 2 decimal places, but I would lose some accuracy in my value from my answer. So now it's your turn to have a go at a few questions. I've placed on the screen 3 questions, 3 sets of brackets. For each question, I'd like you to expand and simplify the bracket using the method we just talked about on the previous examples. There is a little twist in a couple of the answers, so I want to see if you can confidently get to the answer of all 3 questions. Could you pause the video now, show me your full working out, and have a go at these 3 questions? Okay, welcome back. If we look at my answer to question 1, my working out looks like this. So you can see I've even added some arrows on just to remind me of the 4 multiplications I'm doing, the FOIL method, some people refer to it as. 2 times 2 is 4. 2 times negative root 3 is here. Root 3 times 2 is here. And then root 3 times negative root 3 gives me negative 3. But if we look here, when we come to simplify, we have minus 2 root 3's and positive 2 root 3's. So when we add those together, we're left with 0. So essentially, they are being removed from the answer. So the irrational part of my calculation is no longer included. So I'm just left with 4, take away 3. So the answer to this expansion is actually 1. If we have a look at question 2. This time, the working out and the method is very similar to the examples I did on the previous slide. We go ahead and do our 4 multiplications. Again, I've drawn some arrows on there. This is what my line of method would look like. And then I'm left with 6 root 5's and 2 root 5's in the middle, which I'm going to add together to give me 8 root 5's. And I'm also left with 5 and 12, which I add together to give me 17. So I've expanded and simplified. If I have a look at question 3, again, because I'm dealing with a plus root 5 and then a negative root 5 and the same number in both brackets, but just different signs, I'm going to expect a similar result to here. A similar result. So I'm going to expect a number and our irrational part of the question to be removed. Let's have a look if that is the case. Okay, so it looks like this. So I go ahead and do my 4 multiplications, leaves me with this as my line of method, minus 2 root 5s, add 2 root 5s takes me to 0. So again, my root 5s in this question are removed, leaving me with 4, take away 5, which leaves me with -1 in this question. So just be aware that on some of your exam questions or test questions, when you're expanding brackets involving surds, you may find that you're just left with a whole number. If the question is set up similar to this and your irrational part ends up as 0 once you come to simplify. Okay, next task for you to have a go at. I've put on the screen here 5 exam questions. They're all to do with expanding brackets, which include surds. You can see in each question there is a little bit of notation like this: a plus b root 2. Do not let that put you off. All that is telling you is if you expand and simplify this question, your answer should be in this form once you finish and simplify. So it shouldn't really alter any of the method we've looked at so far in this video. Okay, could you pause the video at this point? Could you show me your full working out, and could you have a go at these 5 exam questions? Okay, welcome back. So here is my solutions for the questions we just saw on the previous slide. So for each one, we go ahead and expand the brackets. Question 1 was actually a single bracket question. So root 2 times 3 give me 3 root 2, and root 2 times root 2 give me 2. We could have wrote it in this order as well. So just a single bracket that I put in there as question 1. Then we've got some expansion of double brackets like we've done in the video. You can see exactly what your line of notation and method should look like before you simplify. And then at the bottom of the screen here, we've got an example which is squared. So remember, we write the bracket out twice before we go ahead and expand. And if we look at the last question down here, question 5, you can see that there is a 3 in front of the root 2. So when you write your question out, we're now dealing with a more complex question. I just want to focus on the 4th multiplication. 3 root 2 multiplied by 3 root 2. So first of all, we can do 3 times 3, which is going to give us this 9. And then we do root 2 times root 2. So the root sign would cancel to leave me with 2. And then we would multiply the 9 and the 2 together to give us 18. So the last multiplication here, 3 root 2 multiplied by 3 root 2 would actually be 9 times 2 or 18, which we could then incorporate into our final answer. Very well done if you were able to answer those 5 questions correctly. Okay, here's another task for you to have a go at. So I'd like you to pause the screen at this point, and you can see there is 5 questions on the screen. So each question should follow this method. This is your question. The second cloud should involve your expansion, so you're working out your notation, and the third cloud should be your simplified answer. However, some of the questions I give you the working out and not the original question. Same here, I give you the working out and not the original question. So you need to work a little bit backwards in order to fully complete the questions in front of you. Okay, so I'd like you to pause the video at this point and fill in all the clouds that you can possibly fill in. Okay, welcome back. So I'm just going to move on to show you my solutions. So you'll see all the empty clouds. I'm just about to fill them with the correct line of maths. Okay, there we go. So you can see exactly how each question has progressed. Question, working out, answer. Question, working out, answer. Hopefully you were able to fill in all the blanks that were necessary, so you've ended up with 5 very accurate expansions, which are then simplified. So we're going to finish the video with 3 exam questions. So for the next 3 questions, I'm going to put an exam question on the screen. I'd like you to pause the video, have a go at the exam question, showing me your full working out, and then after each exam question, I'll talk you through the solution and where the examiner would allocate the marks for each question. So starting with exam question 1, this is a 2-mark question. Could you pause the video now, please, and have a go at this question? Okay, welcome back. Let's have a little look at where those marks would be allocated. Okay, here we go. So we're doing the expansion. 3 times 4 is 12. 3 times negative root 2 is negative 3 root 2. 2 root 2 times 4 is going to give me 8 root 2's. And then finally, we've got a root 2 times a negative root 2, which would be negative 2, which we then multiply by this 2. So that's actually going to give me negative 4 at this point. So those would go together to give me this negative 4. So then we can do 12 take away 4 gives me the 8, minus 3 root 2's, add 8 root 2's gives me positive 5 root 2's. You can see where the 2 marks are allocated. There's no answer mark in this question because the question was a show that question. You had to show how you found this solution. So there's no mark available for the final answer. It's your method marks between these 2 steps that are going to get you your marks. So you must have shown some working out to get both marks in this question. Exam question number 2. Okay, could you pause the video at this point, have a go at this question, and then again I'll talk you through the solution when you unpause the video. Okay, welcome back. So this is what my solution looks like this time. I go ahead and do the expansion. So remember, we're dealing with a squared here, so I need to write the question out twice. So don't fall into that trap of just squaring both terms. We need to multiply the full bracket by the full bracket. We go ahead and expand the double brackets. Notice that we're left with a 9 times 2 or an 18 here, because we'd have 3 times 3, which is 9, root 2 times root 2, which is 2, and then 2 times that 9 would be 18. So 1 method mark available for this expansion for ending up with your 4 terms. You may put 18 here, or 9 times 2 is appropriate as well. Then when we simplify, 1 mark for 43, and 1 mark for 30 root 2's when we add both of these 15 root 2's together. Very well done if you were able to get all 3 marks on this question. Last question of the video. Could you have a go at exam question 3? A very difficult question, 4 marks available, challenge question for today's video. Could you pause the video and answer this, showing me your working out? Okay, welcome back. Let's have a look at the solution this time. So the screen shows you where all 4 marks would be allocated. You can see we're working through the expansion of the double brackets, but there's a few tricky bits that come into this question. I'm just going to try and highlight them quickly. Root 50 times root 2 would give us root 100, because remember, we multiply the numbers under the root sign. 100 is a square number, so that's going to simplify down to 10. So when we bring things together, we're sort of left with minus 14 root 2's and 10 root 50's. But that's no good for us because we want our answer. The question asks for our answer in terms of root 18. So what I've done here is I've took the root 50 and I've simplified it down to root 25 and root 2. Root 25 would become 5. So that would simplify down to 5 root 2's. The 5 times the 10 would give me 50. So now you can see what I did was I manipulated that root 50, so I was dealing with the same number under the root sign. So now I've got minus 14 root 2's and 50 root 2's, which I can simplify to give me 36 root 2's. So now at this point, I need to try and manipulate the surd to be a root 18. So what I've went ahead and done is I've split the 36 into two factors, 12 and 3. You can see what I did there. I split it into 12 and 3. And then this 3 is the same as root 9. So then I've changed the 3 to a root 9. So then I've been left with root 9 times root 2, which would take me to my root 18. So you can see there's some very tricky manipulation that is needed throughout this question. And I'm sure there's other ways to approach and answer this question. But the question is asking you to present your answer in terms of root 18. So some manipulation around this part of the notation should take you from your root 50 down to your root 2. So you're dealing with the same root. And then manipulating that value of root 2 to end up with your root 18. Very well done if you were able to have a go at that challenge question. If you were able to understand expanding double brackets and were able to have a go at the exam questions, then that is brilliant. You've shown a very good understanding of expanding brackets that include surds.